force and motion. When there is a change in the position of an object with respect to its surroundings, it is said to be in motion. We can bring a body in motion and can also stop a moving body. Motion does not start or stop spontaneously. We cannot stop a moving vehicle without applying brakes. Even a rolling object stops after rolling some distance as resistance is offered by the ground. Force is required to put a stationary body in motion or to stop a moving body. Force also can be used to change the velocity of an object or direction of motion. The force also can change the shape of a body. When we apply a force on a rubber band, spring, sponge, or mud, the change in shape can be observed. When we push, pull, or hit an object, we make a force to act on them, due to which we can bring the object in motion or can stop it. Force is an interaction between two objects. Force is not visible, but we can see the effects of force. For example, when a book is kept on a table, the table exerts an upward force on it, but it is not visible. All that you observe is the book remaining stationary. When a ball is hit on the ground, it bounces in an upward direction. It is the visible effect of force. Force is a physical quantity that changes or tends to change the state of rest or of uniform motion of a body in a straight line. The force acts along a line in a particular direction and has some magnitude. So, to describe force, we must specify both its magnitude as well as direction along which the force is acting. Balanced and unbalanced forces. When two forces acting on a body are equal in magnitude and opposite in direction, we get the net forces acting on a body equal to 0. The two forces are balanced, so the body remains at rest. In the game of tug of war, when forces acting on both sides are equal, they are balanced. Similarly, when an object is kept on the ground, it remains at rest under the action of weight of object and force of gravity acting on it. Balanced forces do not change the state of rest or of motion of an object. It moves with uniform velocity when forces acting on the object are balanced and there is no net external force on it. But an unbalanced force acting on an object brings it in motion. Due to the unbalanced force, there is a change in the speed of an object or a change in the direction of motion. An unbalanced force is required to accelerate the motion of an object. So as long as the unbalanced force is applied to a body, there is a continuous change in its speed. If the force is removed completely when an object acquires a certain speed, the object will continue moving and then stop moving after some time. The concept of inertia. A body resists change in its state of rest or of uniform motion. You may have experienced this situation in daily life many times. When we travel by a bus and the bus starts moving suddenly from a rest position, we get a jerk. When the bus is at rest, our body is also at rest inside the bus. As the bus is put in motion, the portion of our body which is in contact with the bus acquires velocity. But the upper part of the body tries to remain at rest, so we fall back. The exact opposite situation occurs when a moving vehicle suddenly stops by application of brakes. In this case, our body falls forward because when the vehicle is in motion, our body inside it is also in motion along with it. When the vehicle stops, the lower portion of our body, which is in contact with the vehicle, also comes to rest. But the upper portion tries to retain the state of motion and falls forward. The tendency of a body to resist change in a state of rest or state of motion is called inertia. When no external force is acting on an object at rest, it will continue to remain at rest while a moving object continues to be in motion with the same velocity. Students, now let us see the different types of inertia. Types of inertia. The first type of inertia is the inertia at rest. The inherent property of a body, by virtue of which it cannot change its position of rest, is called inertia of rest. Let us see a few examples. When we dust a carpet by lifting it, the carpet is set into motion and dust remains in its state of rest. Thus, the carpet is cleaned. When a bus starts suddenly, the passengers receive a backward jerk. A fruit falls down from a tree when the branch is shaken. This is because the branch is set into motion, but the fruit stays in the state of rest. The second type of inertia is the inertia of motion. The inherent property of a body, by virtue of which it cannot change its state of motion, is called inertia of motion. Let us see few examples. When a rotating fan is switched off, it continues to rotate. A person falls when he jumps off from a moving bus. Passengers in a bus get a jerk in the forward direction when the bus stops suddenly. The third type of inertia is the inertia of direction. The inherent property of a body, by virtue of which it cannot change its direction of motion, is called inertia of direction. Let us see few examples. While sharpening a knife, sparks fly off tangentially from the grinding stone. When a vehicle moves, the mud sticking to its wheels fly off tangentially. Hence, mud guards are provided to vehicles. As mass is the quantity of matter in the body, we need to exert more force to push a heavier body. Mass is also a quantitative measure of the property of inertia of a body. Hence, heavier objects offer more inertia. The same property is described by Newton's first law of motion. So it is called as law of inertia. Sir Isaac Newton was a great experimental physicist as well as a great mathematician. The laws of motion are known after him. Newton was awarded a knighthood in 1705 for his work and he became Sir Isaac Newton. Sir Isaac Newton put forth 3 laws of motion.